Hey, welcome to day 8 of my Inventor IO 30 Days Lost in Space adventure. In yesterday's lesson, we went over using the photoresistor, and we wrote some logic with an external function that we were able to jump out to from an else statement that we had in our code. We were able to monitor the incoming light and write a counter that would build up until it reached 100%, and then it would trigger or flash an LED. And then I got a little fancy and I created a blinking LED for when it was in partial charge, and then a blue LED to go completely on, and a blue LED that would light up and stay on when we reach 100%. In my off time, I started playing around a little bit more. I bought a box of potentiometers. This is an analog potentiometer, so it takes 5 volts on one side, it takes ground on the other side, and then the center leg sends the variable voltage out to an analog input. And I have 3 LEDs. I actually remembered that I had a bunch of blue LEDs from a guitar that I built back in 2010. I made a 7-string bass with an LED circuit underneath the fretboard, and each of the LED lights, I actually use these flat top ones, if you can see. So I use these flat top LEDs in a circuit to light up the entire fretboard. And the nice thing about the flat top LED is that there's a 120 degree dispersion angle in this LED. So being that the light dispersion was almost flat, I was able to use a fiber optic up against the side of the LED and then translate the blue light up to the side dots on the fretboard. It was a neat project. But ever since then, I haven't really touched an LED. I knew enough back then to make me somewhat dangerous, and that was pretty much where I left off. And as a side note, I made this when I was in high school. I did a 2-week cycle through the electronics shop, and basically this is what they had us do. They had us acid etch some circuit board material, solder in some LEDs, add a 9-volt battery with some resistors, capacitor, and I don't even know what this thing is. Some kind of chip for something. Shows you how much I know about electronics, right? But this was my first delve into electronics, and it wasn't, at the time, it wasn't for me. But we could see that here, when you plug in the 9-volt battery, the red LEDs will flash. So I think this is some kind of timer chip or something like that. So anyway, getting back into what I was working on here, I wired in this potentiometer. This is not part of the lesson, mind you. I added this potentiometer. It's got 3 legs on it, and each of the legs are spread apart to where they fit into the breadboard. They fit into every other socket on the breadboard. So instead of it fitting into numbers 1, 2, and 3, it fits into, let's say, 1, 3, and 5. So from there, I was able to branch out. I put 5 volts into one side, ground to the other, and then the variable voltage to the analog. And then I made some logic so that when I turn up the knob, you see the nice blue LED light up, then the red LED lights up, and then the other blue LED lights up. Then we go down, blue to red to super bright blue to off. Nothing crazy, just a practice. Today's lesson is actually going to cover this multicolor LED, red, green, and blue multicolor LED. There's 4 leads on this LED. So the long leg is it should be the ground, but there's a chance that it could be a common positive and that all these other legs go to ground, because you have 2 choices with these multicolor LEDs. You have a common anode and a common cathode, and depending on which one was in the package will depict which circuit and which code we have to use in this lesson. So let me go to the computer view. We'll go over the diagram. I will wire up the board and we will continue from there. Okay, so I wired my board up the way that it was depicted in the very first diagram, and it does seem to work, but I'm having an issue where the LED light isn't very bright. I'm not sure if that's an issue with the voltage coming out of my USB port, or if it's an issue with the LED or the resistors that were supplied. It is working, but it's not as bright as it's being shown in the video. I did try the alternate solution with the common anode, which is a common positive on the longest leg instead of a common ground, which would be a common cathode LED. As far as the wiring diagram, nothing else really changes aside from supplying the 5-volt power from the other 5-volt output to the rail which ties the second leg of the LED to positive instead of negative. But I'm not quite getting the vibrant result that I would hope for. So here's the code that was written. I'll start a new one again just to get it into my own head. So what we're doing is initializing the pins that we're going to use for our outputs. In this case, we're using pins that supply pulse width modulation, or PWM. So if you look at your hero board, the PWM pins have the little tilde next to them, which is the little whirly jigger here. And so we're defining the 3 outputs for red, green, and blue. In my case, I use a delay time variable so I can set a global delay time. Just a little flavor of my code. We're creating another subfunction. In this case, we're creating a subfunction called RGB color. And this is what I was talking about yesterday, where I was hoping that they would get into passing arguments through the parentheses. Because what this will do is it allows us to define variables inside of this function. So inside the function, we're going to pass 3 variables, one called red underscore value, another integer called green underscore value, and another one called blue underscore value. And what that allows us to do is it allows us to, inside of our loop, we'll see right here, we can use the 3 values by calling up the name of the function, and then inside the parentheses just give it the values of each. So the red value would be the first one, green value would be the second one, blue value would be the third one. Inside of the function that we create, we're just saying analog write red, which is pin number 9, and that ties to red underscore value. Analog write green, and that ties to green underscore value. Analog write blue, which ties to blue underscore value. And then delay, which ties to delay time. Inside of our setup, we just have pin modes to set our outputs. So red, green, and blue. And in the case of the commented out code sections, I was just testing these values because with the PWM signal, what the PWM will do is it will vary the amount of frequency coming out of each of these pins, and that will vary kind of like the voltage. It's a form of variable control, kind of like using a potentiometer or something of that nature, where you take in your 5 volts, you take in your common, and then you have the variable leg where you can adjust anywhere from 0 to 5 volts by turning the dial. The PWM simulates that in the form of a frequency instead of an adjustable voltage. A variable voltage would be an analog voltage, and PWM is kind of like an emulation of analog voltage in the form of a feedback frequency. So the two codes side by side, if I just take this and verify, see if I did anything wrong, it takes it, I can upload this, and all it's going to do is just show me a red LED. I wish the color output were a little better with this multi-color LED. So what I may do is wire up separate red, green, and blue LEDs instead of the multicolor LED. That way we can move forward with the lessons. But I'll go back to the overhead and I'll show you the result that I'm getting as opposed to the result that I would like. And as a side note, I am sorry if there is a fluctuation in the audio. I do have everything set up for a common gain level, but every time I unplug and plug in my microphone to my camera and to the computer, I get a fluctuation in level, and I do try to adjust that in post, but I haven't figured out the rhyme or reason as to what happens with it. But anyway, getting back to the board, if I upload the sketch with all of the RGB color function calls, we'll see that the LED does flash, but it doesn't quite flash as brightly as I would like it to. I'll slow that down, and I'll change these values from 125 to 255, which would give me the proposed full output. And you can see it's not as radiant and wonderful as I would like. The onboard LED is actually brighter than this thing. But I did try doing it the other way with the alternate sketch, and it didn't light up at all, because diodes will only light up with the current flowing in the proper direction, and it only allows the current to flow one way. If I turn the light off, it's still not the brightest thing in the world, but it kind of gets the point across. It doesn't burn bright enough to reflect off of the inside of the LED, but if I kind of pinch my fingers over it, I can make out the different color variations. So this was just a basic introduction to utilizing PWM. I'm going to, like I said, probably rewire this board, and use separate LEDs instead of the multicolor. I would like to use the multicolor, but being that I really don't get the color output that I was hoping for, it's kind of a moot point to try to use it because it doesn't really purvey what they're trying to show in the lesson. So I may have to make a note of that to the powers that be. But anyway, that will conclude the lesson for today. There wasn't a lot to do as far as the wiring was concerned. It was the 5 volt to the photosensor, and then the white coming out to the analog input here. We still haven't tied this back in yet as far as the lesson is concerned. This was just the 5 volt lead going to this common rail that I could use for testing the LED. I've got red, green, and blue on pins 9, 10, and 11, which are noted as being PWM pins. I've got my ground going to the second pin on the LED. It's kind of tough to see because they're kind of bunched together, but if you look at the diagram, I just matched what was on there. And I've got my 3 resistors that tie together for the red, the green, and the blue. So 1, 2, 3. And then as far as the photosensor, we still have the resistor going across and then putting the signal to ground. So I'm going to rewire this a little bit. I will pick back up with an addendum video, more than likely, before I do the video for day 9. Thank you everybody for watching. If you're enjoying this content, please be sure to like and subscribe. Check out my Linux CNC tutorial videos, my CNC machine build videos. If you feel generous, please feel free to help support the page by clicking on my Patreon. Check out my affiliate links for Amazon and for Inventor.io. If you use the coupon code that is in the description, you'll get 10% off of the Hero Board kits, the 30-day Lost in Space, and the other available kits. Thank you again for watching, and we will see you soon. Okay, so as a little postscript to this video, you'll see that I put a blue LED in that I had kicking around. I put a 65 ohm resistor in between. I did the math. Well, I looked up the math on Google, and it said that a 60-ish ohm resistor would give me what I need for maximum output on this bad boy. You can see that the PWM that I have in here, I just have it set to step down at various PWM values. So the light goes bright, and then it just incrementally gets darker, darker, darker until it turns off. So that's what the PWM is meant to do. It's meant to vary the signal going to the LED to change the color values. I was messing around with the multicolor LED, and with the 65 ohm resistor, I do get a very bright output, but I don't think that this is the right resistor for this multicolor LED. What I may do is because I only have so many values of resistor, so the only thing I could really do in this case is to try and either wire this resistor in parallel or series. If I wire two 65s in series, I'll get 130 ohms, which might be closer to the value that I need to not blow out this multicolor LED. But to get the output that I need, I have to drop the resistance enough to allow this thing to give me at least somewhat full brightness. So if I wire these 220 ohm resistors in parallel with the 65 ohm resistor, I may get a value closer to what I need. Let me do the calculation on that right now. I got one resistor is 65 ohm, the other resistor is 220 ohms. Okay, so that gives me the equivalent of 50.18 ohms, which is not what I'm looking for. If I put two 220s in parallel with each other, I get 110. But that's no better than putting 265s in series with one another instead of wiring them in parallel. So I think the best course of action will be to use the 265 ohm resistors in series to give me 130 ohms, or possibly add a third resistor, 65, 220, and 220. So yeah, the best course of action that I've got with the resistors that I have will be the 265 ohm resistors in series with one another. I could always do 3, but I don't think I have that many resistors, because 3 in series would give me, it would get me closer to 220, but it wouldn't get me as much. It would be like 190-ish or something like that. So I've got a couple different plans of attack, so I'm going to try a couple different scenarios and see what gives me the best result, and hopefully at the beginning of the next video for tomorrow we will see this thing lighting up the way it should. Thanks for watching.